In this video, I'm going to show you how to graph a quadratic when you have a front term greater than 1, and I want to show you how it alters our pattern of change. And in a previous video, I talked about how the pattern of change for a quadratic goes something like this. So from the vertex, if you go out 1, you go up 1 times 1, which is 1. And if you go out 2, you'd go up 2 squared, and 2 times 2 would be 4. And if you go out 3 from the vertex, so from the vertex, if you go like right or left 3, you would go up 9. And then 4, you would go up the square, which would be 16, and 5, it would be 25, and 6 would be 36, and so on, the squares. But this is when your A is equal to 1. So if your A is not 1, all you're going to do is multiply these squares by whatever the A is that you have. And so I want to show you how, because this says 2x squared for your lead term, the term that has the highest power, that means we're going to go up double as fast as we normally would. So instead of going up 1, we'd go up double that, which would be 2. And instead of going up the normal rate 4 for 2 out from the vertex, we're going to go up double that, or 8. Because 4 times 2 is 8. And then instead of going from your vertex out 3 and up 9 to get your points, you're going to actually go double 9, which would be 18. And so I want to show you 4 examples of how your rate of change for a normal quadratic, because your y is equal to x squared. So if you plug in an x, if your y is equal to x squared, if you plug in 1, you get out 1. But if you plug in 2, you get out 4. If you plug in 3, you get out 9. So that's why we're talking about plugging in 1, 2, 3, 4, 5, 6, and then getting out a square, because you square your input. Okay, now I'm going to erase this, get this out of my way, because we're going to start graphing now. Okay, here it says, you may graph using a t-chart or by factoring, and I'm going to use, I'm not going to factor this one, I'm just going to use standard form because that's what we have. I'm just going to use the formula for first my axis of symmetry, which is x is equal to your vertical line opposite of b divided by double your a term. My b is 16, so opposite of that would be negative 16, and if I double my lead coefficient of 2, I'd have negative 16 divided by 4, which is going to get me negative 4. So my vertical line that will cut my graph in half will be at negative 4. So if I graph that vertical line, it's going to be here. Now this isn't really part of the picture, but your parabola will alter on either side of that, and it will go up perfectly symmetric around this line. So the left and right of this line will be identical. Now to get my actual vertex, if I know my x is equal to 4, we're going to substitute in for the x the number negative 4. And now what I'm going to do is take 2 times, well, negative 4 times negative 4. I have to do my exponent first. That's going to be 16 positive, because a negative times a negative makes positive. And then 16 times negative 4 is going to get me negative 64, and then we'll add 32. So I have 32 minus 64 plus 32. I'm going to get 0 there. So my vertex was negative 4, comma 0. So I'm actually going to plot that point here on my grid. There's going to be my vertex. Now if this is positive, so A equals 2, it's positive, I know my graph is going to open up, and that means I'm going to have a minimum on the graph, and you track whatever the y value is for that high or low. So how high can it go, how low can it go, that's going to be according to the y value. And the y value means the lowest our graph is going to reach is at 0, and it's going to go up from there. So my next step is going to be here to start graphing my zeros. And actually, if my vertex is on the x-axis, that's going to be my only 0. So now let's start graphing, and you can make a t-table. Now I like to put my vertex in the middle of my chart. So my vertex is at -4, 0. And then what I do is I pick a couple points to the right and a couple points to the left, and I try to graph those. So to the right, I'll have -3, -2, -1. And to the left, I'll have -5, -6, -7. And now I'm going to show you how to type this in the calculator to just kind of make it a little quicker and a little easier. I'll do one of them by hand, and then the rest I'm going to show you how to change on the calculator. So what I'm going to do is substitute in for my x the numbers -7 through -1. I'm going to skip -4 because I already know what that value is, and it will look like this. We're going to have 2, and now since I'm inputting in -7, I need to use parentheses. And what you want to do is type this in exactly as you see it. I'll do only one by hand, and then the rest we're going to do on the calculator, and I'll just confirm this with us. So a -7 times -7 is 49, and 16 times -7 is -112, and 2 times 49 is 98. Okay, 98 minus 112 plus 32 gets me 18. And I want to show you that we will get the same thing if we were to type it all out in the calculator. And I want to show you, we're going to type this exactly into that calculator. So my coefficient of 2 goes down. Now in parentheses, I'm going to substitute in -7. So notice how that's in parentheses. Then I square my x. So notice how that comes next. My square key is right next to the 7. Then I'm going to add 16 times my x, which was plugging in -7. And then I'm going to add 32. And I should get, cross my fingers, 18. Okay, now what's nice is I can go back, and where I see my -7, I'm just going to put right over the 7 key, I'm going to hit my 6 key and change it to -6. And then go to the right and also change that one to be -6. And I'm going to get 8. Now I'm going to do the same thing, but change them both to be -5. So over my 6, I want to see a 5 because I want -5. Oh, went too far. Over my 6, I want a 5. And I get 2. Now I should have, if this is symmetrical, I should have the same values for -3 as I did for 5, -2 as I did for 6, and -1 as I did for 7, because these are supposed to be symmetric as you go up across this vertical line, your axis of symmetry. And so I want to make sure here that I get the same values because it's supposed to be symmetric left and right of your vertex. So I'm going to change this to be -3 and also -3. Oh, yep, perfect. I wanted those to match. That means we have symmetry happening. And now -2. Another one there. Okay, I got 8. Perfect, those match. And then -1. Okay, I got 18. All right, now all I got to do is graph it. So here we go. I'm going to plot these points. From my vertex, if I go out 1, I go up 2 because it went from 0 to 2. And then if I go out 2, I'm going to go up 8. Now I can't go up 18 because that's off my grid, so I'm just going to connect these with a nice curvy U-shaped parabola. Now again, if you notice what we had talked about before, if my A is not 1, I could have just used my pattern of change. From my vertex, if I go out 1, if I double this because my A here is 2, 2 times 1 means I would just have gone out 2. And if instead of out 2, I go normally up 4, because 2 squared is 4, I'm going to double that, so go up. Notice how we went up 8. So if you know this pattern of change for quadratics, it can save you a lot of time of making a table, plugging everything in, doing it by hand, or typing them in again and again and again on the calculator. I mean, imagine the time and efficiency you can save if you know that the pattern of quadratics is you go out like a unit and you go up that unit squared. Your A will alter that. So if you go out that unit and up your square, don't forget to multiply by A if it's not 1. So here we go. Here's another one. I know this video is getting long, but I'm going to try to do this one a little quicker now since we're talking about the pattern. So opposite of B, x equals opposite of b over 2a. I'm going to find my axis of symmetry first. So a is -3, b is 24, c is -36. So opposite of positive will be -24. And double my first coefficient here would be -24 divided by -6, which is going to get me a +4 axis of symmetry. So the vertical line through 4 is going to be where my graph of my parabola is going to go left and right, perfectly symmetric through that vertical line. So it's going to alter this line perfectly on either side. Now my vertex, what I'm going to do is substitute in the value of 4 for my x. And I'm just going to type that right in my calculator. So I want -3, and now in parentheses, I'm going to substitute the value 4 in. I'm going to square that, plus 24. In parentheses, I'm substituting in the number 4, and then I'll subtract 36. And here, I get a value of 12. So my vertex is at 4, 12. And notice how my graph this time does go up to 12, so it looks like I was aware of that when I made my note sheet. So there's my 4, 12. Now, my A is equal to -3. So if I normally go out 1 and up 1, this case, because this is negative, we're going to go down instead. And so instead of down 1 normally, I'm going to multiply that by -3. So I'm going to multiply this. So now, normally we go out 2, up 4, but this case, because our A is negative, we're going to go down. But because my A is not 1, I need to multiply 4 by -3, and we're going to go down 12. Looks like that might be the only one I can do on my graph, potentially. But if I went out from the vertex 3 units, we'd normally go down 9, because 3 times 3 is 9. But I have to triple that and make it negative, so down 27. We're not going to be able to go down much more than that because my grid only even spans 12 to -12, which is 24 units. So I'm not going to be able to do the 4, which is 16, and 16 times -3 is going to be way too many for this type of grid. So let's start graphing. And then again, if this graph opens down, this is going to be the high point, which is our max. So max, and the max you report the y value. The highest it's going to reach is 12, and it's going to go down from there on either side. So out 1, down 1 normally, but we're going to triple that, so down 1, 2, 3. And out 2 normally we go 4, but we're going to triple that. 4, we're going to go down 12. So 5, 6, 7, 8, 9, 10, 11, 12. And this is going to be symmetrical on this side. And then down 27, I have a feeling 27 is going to be way too far. So out 3, down 24, 25, 26, 27, roughly here. So that definitely is off my grid. Over 3, down normally 9, but we're tripling that. 9 times 3 is 27, so this is down 24, 25, 26, 27. Roughly, I'm estimating as best I can there. And so our parabola is going to go down 3 times as fast. 3 times as fast as the normal pattern. Now I can answer my zeros because I see on my grid here my 2 x-intercepts. I have one here at 2. And I have one here at 6. And I notice I forgot my y-intercept here on this picture. My y-intercept, I don't think that I've said this before, but this is the C value of your graph. And I'm sorry, I didn't do this on this one. That would be 32, the C value, because if you plug in 0 for x, you're going to just get your y, your constant. Your y is going to equal that constant because your x terms go away. So again, y-intercept is always 0, comma, a y value. And if you plug in 0 here, this term goes away. If you plug in 0 for x here, this term goes away, and you're just left with your C value, which is -36 is where it's going to cross your y-axis. Quite a bit further to go because here we're at negative, I don't know, 12, 13, 14, 15 roughly. We're only at -15. It's got to go way down to 36 to even cross the x-axis, so quite a bit further. So there's the first 2 graphs. I have 2 more, but I'm going to start a new video to do the next 2.